Hello friends, welcome back. In last video, we saw the basics of control drawing. We also looked into how a breaker closes or opens. Both breaker closing and breaker opening is achieved by breaker mechanism, right? In breaker mechanism, we saw that to operate the mechanism, energy is required, which can be stored either in spring mechanism or in hydraulic mechanism. And this energy is released by closed coil or open coil. Open coil is sometimes also called as trip coil. Closed coil helps to close the breaker, open coil helps to open the breaker. And how this closing and opening achieved is dependent on when the coil operates, which is controlled by our control drawing. In last video, we saw that a breaker closing coil is used to close the breaker. Negative is continuously extended, positive will be extended through various conditions, right? And these conditions put in series will determine the logic of breaker closing. Today we will see each case into detail. This condition can be SF6 gas pressure healthy or unhealthy, lockout operated or not operated, spring charging conditions. Today we will see each of these cases in detail. Let's start with SF6 low. As an operation engineer, when we reach at site, what will we check? We will check the actual gas pressure healthy on an analog switch or a digital indication. How it is achieved in a control logic? Because when control logic is checked, person is not giving any input to the logic. It is taken in auto. The same positive bus and negative bus is extended. Then we will check actual gas pressure through a mechanism called switches. These switches will operate when the gas pressure is actually low. This input is given to contact multiplier. This contact multiplier will have different contacts like open contact and closed contact. Each of these contacts is used in logic for various purposes. Today we will see how it is used in a closing circuit. In closing circuit, we want to check that the SF6 gas pressure should be healthy while closing the breaker. So we will use an NC contact. The logic is such that when none of the SF6 gas pressure contacts is operated, the contact multiplier will not be operated, and in that condition, this NC condition will ensure that our actual breaker pressure is healthy so that we can close the coil. Let's say any one of the phase R, Y or B, any one of the phase actual gas pressure goes low. In that case, this particular contact will operate, and on operation of this contact multiplier will pick up. This contact multiplier will have a coil inside. On operating of that coil, a plunger will be pushed and this contact will change over. So as soon as the R pressure goes low, this contact multiplier will operate, which will cause this NC contact to open. If this particular contact opens, then our breaker will not close. Now let's check the second condition, that is lockout not operate. As the number denotes, 86 is called as lockout or master trip. So what is the purpose of this particular contact? As an operation engineer, let's say we are at site and we want to close the breaker to restore the supply. However, we notice that its lockout or master trip relay has operated. Then in that case, we will not close the breaker, considering that there is some fault in the system in the actual power circuit, so that we should not close the breaker. So for that purpose, we use an NC contact of lockout or master trip relay. So how that is achieved? There would be a lockout relay. Basically, this is also like an contact multiplier. However, once the contact multiplier is picked up, it will hold its condition in most of the cases. It comes with different types of reset. This can be an manual reset in which you need to push the button. It can be an auto reset. In this case, it resets on its own once the command is dropped. Or also, there can be an electrical manual reset. In which you will push a push button and then the lockout will reset. So how this lockout relay will operate? It can operate through an NO contact, which can be our overcurrent protection like 51N. Whenever our relay operates, this particular contact will close, which will make a coil inside this particular lockout operate, which will pull up plunger, and the contact inside it can operate. As we discussed, we want to check a lockout not operated condition, so we will use an NC contact. So let's assume that our relay has operated. In that case, our lockout will operate In that case, this NC contact will change to NO, this contact will open, and our close command will not get through. Now we have checked two conditions. One is SF6 and the other is 86. In SF6 we check that we don't want to close the breaker unless and until SF6 gas pressure is healthy. In lockout, we have checked the condition we don't want to close the breaker unless and until the lockout is reset. So in these both conditions, we used an NC contact, normally closed contact. Whenever this particular condition goes wrong, this particular NC contact changes to open, and in that case, our close command will not get through. Now we will check other conditions like spring charge, breaker test service, etc. In that condition, we want to use an normally open contact so that our close command will get through only when these particular contacts are made. Now let's check how the spring charging contact is taken in circuit. As an operation engineer, how can we check whether spring is charged? We can check by seeing the condition of the spring and what OEM has recommended. If OEM has said that in compressed condition the spring is charged, then we will see whether it is in compressed condition, we will consider that the spring is charged. How our control logic will understand that? For that purpose, this particular mechanical movement is converted into an electrical NO or NC contact, potential free NO or NC contact using limit switches. This holds true for spring charging condition or test service condition. So how that is achieved is based on the limit switches. The limit switches are provided in such a manner that they will change over in case of change of condition. That is, there will be an NO or NC contact in a limit switch such that whenever spring is charged, it will change over. The limit switch is arranged such that whenever spring is charged, the contact will become closed from NO and open from NC. Those limit switches are wired in such a way that whenever spring charges, this particular contact will close, which will again pick up a coil inside contact multiplier, which will have multiple NO and NC contact, and one of which will be used for our circuit. So as discussed, we will use an NO contact for spring charging. So as soon as the spring is charged, this particular contact multiplier will operate. This contact will change from NO to close condition, and it is sensed by our closing circuit, which will ensure that the close command will get through only when spring is charged. The same logic goes for test and service. There is another condition checked for breaker open or close condition. How that is checked? If we want to close the breaker, then we will ensure that the breaker is already open. Why this condition is necessary? This condition ensures that the command will get through for a momentary period. If we are trying to close the breaker, then the command will drop as soon as the breaker is closed. So this contact is taken either through contact multiplier or directly through a mechanical arrangement. To summarize what we have understood today, we have understood different conditions in a closing circuit. All these conditions are put in series. Why series? Because we want to check all the conditions. We want an AND logic where all the conditions are checked. We have seen each condition in detail. Is it necessary to have all the conditions? No. Can we have multiple conditions? Yes. So on which things does it depend? It depends on our design and requirement. So it can vary from drawing to drawing, but the basics remain the same. So we are clear with the basics of understanding the breaker closing circuit. If this is clear to you, you can start with your own drawings and comment in case of any doubts. In next video, we will try to see the tripping circuit of a breaker. Stay tuned. Thank you.